I'm Tiasing. Today we're going to talk about the application of the decision tree in the manufacturing context. So a little bit about myself, I'm Tiasing. I'm a product engineer from HP Singapore. I work in the manufacturing environment and I like discovering new things and I also like playing with data. In my work environment, I deal a lot with problems. I solve problems and I use data a lot for analysis to learn about a process or product performance. So some of the key challenges that in general most people face, even in manufacturing, are that it is very difficult to obtain data, transform them, and prepare them before we can even analyze them. So this one takes a long time. So that results in taking too long to identify an issue. So the next few slides we'll be talking about the application of decision tree. Decision tree is commonly known as one of the most popular machine learning techniques for classification and prediction. And also, we'll also talk about using decision tree as a data mining techniques. The slides here shows how we can apply machine learning to solve business problem. So the goal here is to learn from data and to learn how to classify and predict a pass or fail sample based on its previous series of input process data. Okay. The reason why we want to do it is because we want to see if there is an increase in the failure so that we can trigger the downstream partners before the actual failure happens. This can help us to reduce the exposure of the defect parts built, thus reducing the cost of quality. This is a video demo of the program, a small little program that I wrote. I spent a few days writing a program to actually clean, transform the data before it can be modeled. So this data, I split the sample into train set and test set, and I model it using a decision tree. So this slide shows the summarized model evaluation and the results. In general, based on accuracy and precision, it looks okay. The ROC curves also shows that this is better. The prediction is better than just random guessing whether it's pass or fail. However, do take note that the recall is very low, about 61%. This implies that if we are interested in detecting the fail parts, then there is about 40% of the time we might misclassify. So this is actually not very good. So now we're going to talk about how to use decision tree, how I use decision tree for data mining and to understand what to solve a mystery. So there's this case study where we have to identify the culprit. I have a data set with me, real data set of 1,000 over records. And there was a period recently for March, there was a high failure spike in some testers at the end of the stations. So we were scratching our head, what could be the problem? So how I go about doing it is can be visualized in this process flow. Data extraction is taken from SQL, and then I make use of R to help me to do the data cleaning, pre-processing, and transformation before it can be analyzed. So the best split would be depending on whether it is from machine 1 or machine 2 in the process A. So what you can learn from this chart is that you can induce that the product that is built in process A, tooling number 2, has a good yield. Therefore, it is not a problem. The other key takeaway is that there is a high percentage of failure parts that are all coming from machine 1. The decision tree actually further breaks down to help us to time bound our problem. Here we notice that anything that is built after 6 a.m. has no issue. And from this simple example, we have identified that the main culprit that caused the high failures on downstream is actually this machine number 1 of process A. You have seen the real demo of the decision tree mining techniques, and you can see that the power of data mining using decision tree. It can help us to analyze. So you can see that these are the key benefits of the data mining using decision tree.